Today I will be doing an experiment to prove that this law works. First, I will take 215 milliliters of water and pour it into this water bottle. Next, I'm going to mark where the water is. Okay, now that I've marked where the water is in the water bottle, I'm going to put it in the freezer for a couple of hours. The temperature of the freezer was negative 19 degrees Celsius, so I added 273 in order to change it to Kelvin and since it's 254. The temperature of the water before was room temperature at 23 degrees Celsius, so I added 273 to change it to Kelvin. The volume of the water before was 0.250 liters, and the volume of the water after is what we're trying to find. V1 over T1 equals V2 over T2 is Charles's law, so now I've plugged in our numbers. 0.250 liters is our first volume of the water in the water bottle before we put it in the freezer. 254 is our first temperature, which is the temperature of the freezer. X is what we're trying to find, which is the water after it was frozen, and 296 is the temperature of our water. So I cross multiplied, 254x equals 74, divided, and I got x equals 0.29133 liters. Then I subtracted 0.250, and I got 0.04133, and that is the total increase of water. Find the percent error of Charles's law. So I use the equation AY equals 0.0413 and TY equals 0.0414. So I put the original over the next and then multiplied by 100, and my percent error was 99.7585%. For the second part of my experiment, I'll be demonstrating Boyle's law, which states that as pressure increases, volume decreases. As the volume increases, pressure decreases. This is Boyle's law. Materials you will need for this experiment are baby marshmallows and a knife. So I put one marshmallow inside the tube. Since the air around us is 1 atmosphere, if I do not cover the end of the tube, the pressure inside the tube will stay at 1 atmosphere. But if I cover it and press down and decrease the volume, then the pressure will increase. And if I pull away, the pressure will decrease and the volume will increase, giving the marshmallow more room to freeze. So I'm going to set the medicine tube at 5 milliliters and the pressure will still be at 1 atm. So when I push it down to 3 milliliters, the marshmallow decreases because the pressure has increased. Now I'm going to pull it to 8 milliliters, and the marshmallow increases because the pressure has decreased and the volume has increased. Now let's do the math behind this problem. The normal pressure of the tube at 5 milliliters is 1 atm. The normal volume of the tube is 5 milliliters, or 0.05 liters. The pressure with the air coverage volume increasing and decreasing is what we're trying to find, and the volume of the air coverage is 0.03 liters divided by 0.08 liters. So using Boyle's law, I know that our first pressure is 1 atm, our first volume, 5 milliliters, our second pressure is what we're trying to find, and our second volume is 8 milliliters. So I plug this into the equation, putting 1 atm in for P1, 5 milliliters in for V1, X for P2, and 8 milliliters for V2. I ended up getting X equals 0.625 atm, and when I subtracted it from 1, I got 0.375. Then the pressure with the volume decreasing, my P1 was 1 atm, V1 5 milliliters, my P2 was X, and my V2 was 3 milliliters. So when I plugged it into the equation, I got X equals 1.666 repeating atm. When I subtracted it from 1, 0.666 repeating atm. Now it's time for us to find the percent error of Boyle's law. To find the percent error of the pressure with the volume increasing, I used my numbers that I had from our previous calculations, put 0.631 over 0.625 times 100, and my percent error was 100.96%. Next, I had to find the percent error of the pressure with the volume decreasing, so I used our previous calculations, 1.657 over 1.66 repeating times 100, and I got 99.4598%. Thank you for watching my experiment on Charles's and Boyle's law.